I saw your question on evaluating this 3x3 determinant here. There are a couple ways to evaluate this. I'm going to post a link on my announcements tomorrow with a video shows a second way to work this problem, which students often like. One way to evaluate determinants is to copy down the top row of numbers, a 3, 7, and a 4. 3, 7, 4, and always change the sign of the middle one. And then if you look at this, now I wrote 3 and you don't put a matrix here, minus 7 in a matrix here, plus 4 in a matrix here. Or determinant. What determinant goes here? Well, if you look at this 3, it's in the top row and left column, and that would leave these 4 numbers here out. That's what belongs in this determinant. And so that'll be 9, 7, and 2, and 5. Now you do the same thing for the next number, the 7. It's still in the top row, but the middle column, and you'd leave out these 4 numbers here, 1, 8, and 7, 5. So 1 and 8 and 7 and 5. And the last number 4, still in the top row, right column, would be left. These 4 numbers would go in this determinant, 1, 8, 9, 2. 1, 8, 9, 2. Now you want to take 3 and multiply it by the value of this determinant, 2 by 2. So you multiply this column, or this diagonal will be 45 minus this diagonal, which would be 14. So it'll be 45 minus 14. And you continue across here. This diagonal would be 5. This diagonal would be 56. 5 minus 56 plus 4. And finally, this diagonal would be 2 minus 72. And so I have 3 times 31 minus 7 times negative 51 plus 4 times negative 70. So let's see, what would that would be? 93 plus, see, 51 times 7 would be 357, I believe, minus 280. And let's see if I combine those numbers here. 93 plus 357 minus 280 gives me 170. Several steps involved here, but that's how this is one way to evaluate a 3x3 determinant. Hope this helps.